So in this example, again, we're dealing with just numbers, so a diagram isn't appropriate. We can jump straight to the function. We have the sum of these cubes. So we need to define two numbers. Call them x and y. We're talking about the sum of the cubes, so the sum would equal x cubed plus y cubed. This is a situation in which we need two functions. If we were to deal with this the way it is, x cubed and y cubed, two different variables, we need to use implicit differentiation. The other thing that we know about these functions is that they have a sum of 10. So we know that x plus y is 10. Or we're going to make it a little bit easier for us to deal with, y equals 10 minus x. So then what we can do in a sum equation, instead of y cubed, we can substitute in 10 minus x for y. There's our equation. The domain of this function, a little bit different than the last one. These are two non-negative numbers having a sum of 10. Non-negative includes 0, so we could have numbers as low as 0. The largest number that we could have is 10. If we were to allow, let's say, 15, 15 plus what has a sum of 10? Well, negative 5. But we know that these numbers are non-negative, so we can only be between 0 and 10. Square brackets, because we could actually have either of those numbers. We've got the function, we've got the domain. Take the derivative. So derivative of x cubed, 3x squared. We need to use the chain rule on this next bracket. 3 comes down. 10 minus x squared times negative 1. And before I set this equal to 0, I'll do a little bit of simplifying. And so now setting this equal to 0, this is what we end up with simplified. And I just realized I made a mistake up here. That should be plus 60x, so minus 60x over here. And we'll get x equals 5. So x equals 5 does fit in the domain. It is considered a critical number. Again, we have to test for the minimum. So if we test x equals 5 into our sum function, we get a sum of 250. We do actually have to test the endpoints of the domain here because we have square brackets. They can be included. So test x equals 0. And repeat with x equals 10. So now looking at these test points, we have to go back to the question. We're trying to find the sum of these cubes to be a minimum. Well, taking a look at the answers that we got, 250, 1000, and 1000, the minimum, the smallest, 250. So what we know is that the numbers Well, 5, because that's what we tested. 5 and what? Well, we know that the numbers have a sum of 10. So in order for 5 and something to have a sum of 10, the other one has to be 5. And the other thing we know is that the minimum sum is 250.